All right, here we're being asked to solve a power equation with a rational exponent. The first thing to do here is to rewrite the rational exponent in its radical form. And that would look like this. Again, just a quick reminder of these rational exponents, that the numerator is the power or an exponent, and then the denominator, we think of this as the index of a radical. That's the definition of these rational exponents. So what I'm going to do is I can do in either order the radical and the power, but what I'll do is a radical of index 2, which is a fancy way of just saying a square root, and then I'm going to raise it to the third power. So again, all I've done here between these steps is I've just rewritten that rational exponent. And now I'm going to solve this with all the same tricks we've had before. The first thing I'm going to do is I'm going to apply the cube root to undo this cube right here. So I'm going to cube root both sides of this equation. When I do that, what I'll get is the square root of 5x plus 5. Again, cube rooting it has gotten rid of that exponent of 3. Those cancel each other out. And then the cube root of 8 is simply just 2. And then now what I'm going to do is I'm going to raise both sides to the second power. I'm raising both sides to the second power to undo this square root right here. By the way, as we previously talked, if I raise both sides of an equation to the second power, there could be an issue with me creating extraneous solutions when I do that. I'll just say, with the examples that we're doing, we don't need to worry about that. That would just be a case if one of these sides came out to be a negative. That's not an issue here. Anyways, so I just square both sides. What I get is 5x plus 5 equals 4. And this is simply just a linear equation that I can solve. It's a two-step linear. Subtract 5 from both sides to get 5x equals negative 1. Divide both sides by 5 to get x equals negative 1/5. So again, just a quick review. What I'm going to do is just rewrite this rational exponent in radical form. Then I attack the radical and that exponent. It doesn't matter which order I do that. I always take care of the exponent here first by, in this case, this 3, or cube. I cube rooted both sides to get rid of that. Then I'm going to take care of the radical of an index 2, or take care of the square root by squaring both sides. That gets rid of the square root. Basically what I've done is unlocked this stuff inside the radical and solved the linear equation.